Hello friends, welcome you in my YouTube channel. I am Dr. Muhammad Sirajul Akfaisi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Friends, today in this video, I am going to explain about air chemistry. So, let us start with me to learn air chemistry. So, first you learn types of matter. You know the matter is three types: gases, liquids, and solids. Air pollutants, gases, particulate matters, can be either solid or liquid, or often a combination of both. So, look at the table classification of matter, observable properties, and atomic theory. Element cannot be broken down into simpler substances, only one kind of atom. Compound, fixed compositions, but capable of being broken down into elements. Two or more atoms in fixed combinations. Mixture, variable compositions of elements and or compounds. Variable assortment of atoms and molecules. So friends, parts of an atom normally have negative or more protons, positive charge, zero or more neutrons, no charge, minus one or more electrons, minus one charge. So here it should be positive. Chemistry depends on the number of electrons, which in turn depends on number of protons. Thus, the identity of an element is determined by the number of protons in its nucleus. So, this is the arrangement of elements in the periodic tables. Atomic number, symbol, name, and atomic weight. This is atomic number, this is the name, this is symbol, and this is atomic weight. So rounded approximately the mass number, number of protons and neutrons. So organic compounds, carbon-based chemicals. Some examples: propane, hydrocarbon, ethanol and alcohol, acetic acid and organic acid, dichlorobenzene, chlorinated hydrocarbons. Inorganic compounds, chemical other than those based on carbon, although some contains carbon, as carbonate, sodium chloride, table salt, water, sulfur dioxide, calcium carbonate, limestone, and ferric oxide, rust. Reaction in equation. Reactants give products. For example, consider the combustions of carbon. Carbon combined with the oxygen forming carbon dioxide. Note that matter and number of atoms are conserved. So, characteristic of chemical reactions: always conserve. Number of atoms in reactants is equal to number of atoms in products. Identity of atoms in reactants is equal to identity of atoms in product. Total mass of reactants is equal to total mass of products. Not necessarily conserved, number of molecules of reactants may or may not equal number of molecules of products. Volume of reactants may or may not equal volume of product. So, balancing chemical equations. Since the number of atoms of each element involved is conserved, the equation describing chemical reactions must be balanced. For example, CH4 react with O2 gives carbon dioxide and water. So start with the most restricted terms: 1, 1, 2, 2. So check it is balanced or not. Now, atmospheric and weather terms. What is troposphere. The parts of atmosphere from ground level to 10 to 12 kilometer height comprises about 80% of mass of atmosphere and nearly all of the water, vapor, clouds, precipitations and air pollutants. That is called troposphere. Stratosphere, the layer of atmosphere from 10 to 50 kilometer above the surface of the earth contains about 20% of mass of the atmosphere. Few air pollutants get this far, but there are important exceptions. Here is where oxygen and ozone filter out most of the dangerous UV light from the sun. Atmospheric and weather terms. Palam, the zone downwind of a pollutant's source, where the concentration of pollutants is higher than backgrounds. Atmospheric stability. What is this? Right, friends? The level of air velocities due to wind, mostly horizontal movement, and temperature differences that can create vertical movement. Right, friend? Pollutants tend to stay concentration in stable air and disperse rapidly in unstable air. So, friends, just remember these two words, palam and atmospheric stability. Now, inversion. In the troposphere, the air temperature generally decreases with height above ground under inversion conditions. The temperature increases, inversion are temporarily, but they create stable air and cause pollution to become more concentrated while they last. So, supporting concept, units of concentration, unit conversions, ideal gas law, molar volume, significant figure. You should know these things. So, unit for importance unit, ppm and ppb. If you are talking about air chemistry, then always they report in ppb, part per billion and part per million for gases. Microgram per cubic meter for particles and gases. Microgram per cubic meter, microgram per cubic meter, this is for liquids. Part per million or billion. For gases, the basis is volume. Volume of pollutant per volume of air. For example, 1 ppm of gaseous pollutant is 1 cubic meter of pollutant per 1 million 10 to the power 6 cubic meter. 1 cubic meter, not per cubic. 1 cubic meter. Here, per cubic meter, meter. 1 liter of pollutant per million liter of air. Similarly, part per billion is per billion volume of air. How you convert? So, percentage to ppm. You have 0.036% CO2. So, convert it 0.036 cubic meters carbon dioxide and 100 cubic meter air. Multiply both sides by 1000, 10,000, then you will get this value, 360 meter cube CO2 or cubic meter 10 to the power 6 meter, cubic meter air, and it become 360 ppm. So if you have the percentage, so go by the step by steps, this by 100 and multiply 10,000 and divide 10,000, and then you will get this value, and then you will get, so 0.036 percentage is the actually 360 ppm. Moles in atomic weight. A mole of anything is Avogadro's number, 6.022 into 10 power 23 of those things. A mole of chemical is therefore 6.022 into 10 power 23 molecules. For reference, the universe is thought to have existed for about 10 to the 18 seconds. The atomic weight of an element is the weight of 1 mole of those atoms. We can find this on the periodic table. The atomic weight of carbon is 12 gram per mole. Look at here. This is the carbon, this is the symbol of carbon, and this is the atomic number, this is the mass number. Molecular weight. The molecular weight, sometimes called formula weight, of a chemical substance is the weight of 1 mole of its molecules in grams. The molecular weight of water is 80 gram per mole. You can calculate because you know this is contains oxygen and 2 hydrogen. Why? So here oxygens, here hydrogens. So molecular weight, the molecular weight sometimes called formula weight of chemical substance. 1 mole of water is therefore 18 gram of water. The molecular weight of table salt is 58.5 gram per mole. 1 mole of table salt weight 58.5 grams. So here is sodium, here is chlorine. So here is the mass and here is the mass just combined together. Now gas law. The ideal gas law describes quite accurately how most gases under typical environment conditions respond to change in those conditions. PV is equal to nRT. P is total pressure in atmosphere, V volume in liter, N number of moles of gases, R gas constant 0.0821 liter atom per mole per Kelvin, and T absolute temperature in Kelvin, which is 0 degrees Celsius plus 273. So friends, this is already clear to you. Molar volume, this is very basic. The molar volume of ideal gas at 1 atmospheric pressure and 0 degrees Celsius is 22.4 liter. For more typical environmental conditions of 20 to 25 degrees Celsius, the molar volume is approximately 24 liter per mole. That is very important for the air chemistry unit conversion ppm or ppb to microgram per cubic meter. For most calculation, we can assume the gaseous pollutants behaves as ideal gas. At any typical ambient temperature to 20 to 25 degrees Celsius and atmospheric pressure, 1 mole of an ideal gas occupies about 24 liters, 24.4 liter at 0 degrees Celsius. Molar volume approximately 24 liter per mole. 1 mole of any chemical substance weight its molecular weight in grams. Molecular weight of benzene 78, 1 mole is 78 grams. So unit conversion ppm or ppb to microgram per cubic meter. Example, convert 10 ppm benzene to microgram per cubic meter. Molecular weight of benzene 78 gram per mole. 78 into 10 to the power 6 microgram per mole. So 10 ppm is equal to 10 liter benzene divided by 10 to the power 6 liter air. So look at here. This is the 10 ppm, 10 to the power 6 liter air, 78 into 10 to the power 6, 24, and then 32,000 microgram per cubic meter. Similarly, 10 ppb is equal to 32 microgram per cubic meter. For more precise calculation, this is very important how you convert ppm to microgram per cubic meter, these conversions. For more precise calculations and significantly different temperature or pressure, use the ideal gas equations. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel